In this tutorial, we're going to talk about section 9.3, rotations. And simply, a rotation is when a figure is turned in a clockwise or counterclockwise direction about a center of rotation. So let's take a look and see exactly how we're supposed to rotate these figures. So our first example, we're going to draw the image of triangle EML for a 90-degree rotation about A. So we first of all have to know where A is. Okay, so here's point A and triangle EML. The way that we're going to rotate this figure 90 degrees about A is we are always going to rotate in a counterclockwise direction unless otherwise told so. So here's what we want to do. I want to try to create an angle, if at all possible, with each of these points. So I'm going to work with point M first, and it's this far away from point A. Well, after I rotate this figure about A, it will still have the same distance away from A. So what I'm going to try to do from this line is to sketch out a 90-degree angle. And a 90-degree angle is a right angle, so it should look something like this. And I'm going to try to make it about the same length as I did before. And I'm going to call this M prime. So that's where my M is going to be after that 90-degree rotation. So let's do the same thing with point L, right here. So I'm going to do the same exact thing. I'm going to create a straight line with A, just like this, and then I'm going to make a right angle the best that I can. And it's okay if it's not perfect, and I'm going to try to make it the same distance, and I think that's pretty good. So this is going to be L prime. And then the last point is point E, and I'm going to connect him to point A as well, like this. And once again, a 90-degree rotation. So that's going to be somewhere over here. And I think that's a little too far, so probably here. This is going to be E prime. And after you sketch out all your points, you're just going to connect them, and you should have your rotated triangle. And it does look a little sideways, and that is okay. Okay, so now what about a regular polygon? Regular polygons have a very unique kind of center. So here we have a regular pentagon, or at least we're going to assume that it is. What we mean by regular polygon is that all the sides and angles are congruent. So here, this is congruent to this, and this, and this, and this, and it's all good. So the center of rotation for any regular polygon is the very center of that shape. And in other words, this point, whatever its center is going to be equidistant from each of these vertices. Now, of course, this figure can be rotated about a different center of rotation. But for this particular example, we're looking at the center of rotation within a regular pentagon. So what we want to first determine is where each of these points are. If this is A and B, C, D, and E, and I want to rotate these points so that it lands on top of another one, I have to know the kind of angles that I'm dealing with. I have to know how big this angle is right here in order to do any of these rotations. So remember that the way that we figure that out is by, first of all, going back to that old equation where it said the number of sides that you have minus 2 times 180 gives the amount of degrees within that figure. Since this is 5, I'm going to have 5 minus 2 to give me 3, and then times 180 is going to give me, let's see, 540. Now that's being split up equally into 5 different angles, so we need to divide this by 5, and that's going to give me 108 degrees. Okay, and that's the measure of all these angles on the outside, right? So how then do I find the measure of this one on the inside. Well, if you look here, this whole thing creates one big circle. And I happen to know that there are 360 degrees within a circle. So let's divide that by 5 and see how big each of those angles are. And it happens to be that it is 72 degrees. Okay, so note the difference. This part here will tell me the angle of these inside angles, which is what I need for rotation, whereas this guy over here only tells me how big the angles of the figure are. So when we're doing these problems, this is not our main priority. It's this guy over here. So let's say I start at point B, and I am going to rotate that 72 degrees counterclockwise. And if all of your angles are positive and it doesn't tell you how you're rotating, you are going to assume that you're going counterclockwise. So since each of these individual rotations of 72 degrees represent me going from this point B to point A, that's exactly where I'm going to be. So point B is going to turn into point A. All right, so then what about if I move point A 144 degrees? So you first of all want to figure out how many rotations that is. So divide that by your 72 degrees, and that's going to give me 2 rotations. So A is now going to be from here to E, that's my first rotation, and then to D. So point A is going to go to point D. So that's how we do those kinds of problems. And that's going to conclude this tutorial.